So today we're going to talk about some more transformations and how that looks on the coordinate plane. Some of the problems I talk about will not show an actual coordinate plane. We will just have coordinates themselves to look at. Just like this one here. So we have square GYTD. It has vertices at G, Y, T, and D with these coordinates here. And we're telling you that this square is translated to form G prime, Y prime, D prime, T prime, and D prime. So we'll get those set up here. Alright, it's important to note what direction they say it's translated. So if we're going to go 2 units to the left, that refers to the x coordinates of those points. And going left on the x-axis is like subtracting 2. So each of the x coordinates we need to subtract 2. So this -4 minus 2 is -6. 0 minus the 2 is -2. Again, 0 minus 2, -2. And lastly, the -4 makes a -6. So those are the new x coordinates after translating 2 units to the left. The 2 units up, that refers to the y coordinates, and the fact that we are going up means we are adding 2 to each of the y coordinates. So for G, 3 plus 2 gives us 5. This 3 again makes a 5. 3 plus 2 makes a 5. -1 plus 2 makes a 1. And the -1 here plus 2 makes a 1. So if we were to plot this translation of GYTD to G prime, Y prime, T prime, D prime, it would have these 4 new coordinates right here. Let's look at another one. This time we're asking what was the transformation. So we have the vertices of figure STUV, a quadrilateral, has these coordinates. The vertices of S prime, T prime, U prime, V prime have these coordinates. And the question is, what transformation of the figure STUV produced S prime, T prime, U prime, V prime? Now, since the transformation affected all 4 points equally, all we need to do is pick out one of the pairs of points. So let's focus on S, -2, 2. And a transformation happened and it turned into what is now known as S prime, 2, -2. Keeping in mind, when you're looking at XY coordinates, it sort of tells you a direction. That's how we plot points. The X coordinate refers to a left or right direction. The Y coordinate refers to going up or down. Going left on the x-axis is like subtracting. Going right is like adding. Going up is like adding on the y-axis, and going down is like subtracting on the y-axis. So we went from -2 to +2, and that's our x coordinates here. So for x, if I go from -2 to +2, on the x-axis, that's a distance of 4, and it's a distance of +4. That tells me about the horizontal distance. This figure moved to the right 4 units. Now let's focus on the y coordinates. We went from +2 to -2. If I'm on the y-axis and I go from +2 to -2, I went a distance of 4 downward. I went in a downward direction. that means I went -4, down 4 units. So to describe this transformation, it was what we call a translation, and the direction it translated was 4 units to the right and 4 units down. Alright, so here's another example. That was another example of how a figure moved, but we didn't have the luxury of looking at a graph. This next one we look at, we will have the graph. We do see the graph here. We have figure ABC, looks like a quadrilateral, not a particular type, just a 4-sided figure. And it tells us that we want to reflect it across the y-axis. So there's a mirror image of it on the other side of the y-axis. And those 4 points, those 4 new points, will have the points called A prime, B prime, C prime, and D prime. Well, the mirror image of A is A prime. The mirror image of B is called B prime. Notice it's 1, 2, 3, 4, 5 units away from the y-axis. So I'll match that up here. Here's my B prime. C is right in line with A, and it's 1, 2, 3, 4 units away from A. 1, 2, 3, 4. So here's my C prime. And then finally D prime, 4 units here from the y-axis. 1, 2, 3, 4. And I'll try to connect these the best I can with a straight line. It's not very straight, but hopefully you get the idea. Let's try to straighten that up a little bit. There we go. So the mirror image close to it, and we're trying to figure out what those coordinates are. Well, if you look at A prime, the coordinates are 1, 4. 1, 4. Look at B prime. Those coordinates are 5, 8. 5, 8. Look at C prime. Those coordinates are 5, 4. 5, 4. And look at D prime, 4, 2. And again, this is the result of reflecting that image across the y-axis. It's the mirror image. Every point corresponds to the other point. It's labeled with just a prime, but we wanted to point out the coordinates of this new figure. Let's look at another one here. This time we're going to be focusing on a line. We're going to actually reflect a line, and it is possible to do that. Okay, so there's this line AB, which is not drawn. AB right here is not drawn. What is drawn is A prime, B prime. And yeah, this doesn't show up very well, so I'm going to enlarge these. A prime and B prime. That's the points that are shown right now. It does tell us the coordinates of point A are at 0, 2, and the coordinates of B are at 2, 5. Now these are sort of the reflected points of A prime and B prime. So A prime and B prime already showing on the graph. A is at 0, 2. I'm going to plot that. So here's A right there. And B is at 2, 5. I'm going to go right 2. I'm going to go up 5. Here's B. Okay, now it's a little hard to tell. I'm going to try to draw this as straight as I can. I'm going to draw a line connecting A and B, and so we kind of see the mirror image. All right, now this is a reflection, they tell us in the problem, and we're trying to figure out what line is this reflected over. It's not reflected over the y-axis. It's not reflected over the x-axis. However, there is this line right here that goes right through the origin. It's diagonal, and that line has an equation. That line has the equation y equals x. Okay, now if you're not too familiar with the equations of linear equations and how they look and how they're constructed, that's for another lesson. But this dashed line that I drew, just know that the equation for that is y equals x. Alright, some call this being reflected over the origin, but it is in fact reflected over this line y equals x. Here I even label it on the graph. There we go. So AB, line AB, and line A prime B prime are reflections of each other, and they are reflected over the line y equals x. Last one. Finding the right reflection. And actually, I don't think this is a reflection problem. I'm going to mark that out. This is actually a rotation problem. Notice we talk about rotation right here. So this is a rotation problem. It's not a reflection. They say that segment AB is rotated to form the line segment A prime B prime. Again, they're giving us A prime B prime. I'm going to accentuate them, make them a little bigger. Down here is what we call A prime B prime. They tell us the coordinates of A and B, and they also told us a clockwise rotation happened. So like the directions of a clock, it spun in this direction, clockwise. And it went around the origin. That's sort of our hinge, our axis that is spun around. What we're going to do here is plot the points A and B. A is at 1, 5. Here's 1, 5 right here. That's A. And then negative 6, 4 is B. There's our B point. And then we're going to connect these with a straight line, straight as we can here. So what happened is we had a clockwise rotation, so it rotated in this manner. Picture this A prime, B prime, rotating up and matching up. Notice how the A lines up with the A prime, B lines up with B prime after we rotated around. And to arrive at that location, it didn't do a full circle. It looks like it did just about a half circle. Like if we start here and we went about to here in a clockwise manner, the amount of rotation was 180 degrees. It sort of made a half circle, 180 degrees. Alright, so that is how we can describe this rotation. It rotated clockwise 180 degrees. Thanks for watching this video. Have a nice day.